So let's start with going from consumer theory, utility maximization, to estimating a demand curve, which is the relationship between price and quantity. We already talked a lot about the theory of how we move from utility maximization to a demand curve. And the model predicted that a demand curve slopes downward, so that quantity demanded falls as prices increase. Now we're going to estimate a demand curve using regression analysis and see if the results match up with the prediction. So let's consider the market for apples. We have a data set that was compiled from telephone surveys of 660 household heads, and they were presented with randomly selected hypothetical prices of regular and eco-friendly apples. And the heads of household were asked how many apples they would purchase at those prices. So here are some variables in my data set. I have an ID number, I have education, which is the years of education, the date of the interview, the state where the family lives, the price of regular apples, and the price of eco-friendly apples. I have a dummy variable that indicates whether or not it was November when apples are perhaps picked. Household size variable, a dummy male variable, family income measured in thousands of dollars, age of the household head, the quantity of regular apples that the household head said would be purchased. Here it's been converted to pounds, and the pounds of eco-friendly apples that the household said they would purchase. And then there's some information on the ages of the other household members. So we know that price of eco-friendly apples needs to be a part of estimating the equation for the quantity demanded. So here we have eco-pounds is equal to alpha plus beta times eco-price. We would expect, given that demand curve slope downward, that the beta should be negative. As the price goes up, the quantity goes down. So I have run this regression in a statistical package, and here are the results that I find. So here's my coefficient column, and if I wanted to write out the results, I would say, okay, eco-pounds predicted is equal to 2.4 minus 0.845 times eco-price. So if the price of eco-friendly apples went up by 1, in this case $1, then the quantity of eco-friendly apples that would be purchased falls, in this case by 0.845 of a pound. The important thing is there's a negative relationship between the two, i.e. we have a negative coefficient, so that as price goes up, quantity falls. Theory, however, tells me that I should include other variables in my model. Based on what's available in the data, I'm going to include the price of regular apples and family income. We know that if income goes up, the budget constraint shifts out, and the family can move to a higher indifference curve. And if the price of regular apples goes down, the demand curve for eco apples would shift in. Because if the price of regular apples goes down, people will buy more regular apples, and they will buy fewer eco apples. So I have included my other variables in my regression, and I find the following results. So predicted eco-pounds is equal to 1.8 is my constant, or intercept, minus 2.9 times eco price plus 3 times regular price plus 0.003 times family income. Okay, so what do I find here? I still find a negative relationship between eco price and eco pounds, so that still holds, which it should. That's the law of demand. Regular price, that's the price of regular apples. If the price of regular apples goes up, I'm going to stop buying as many regular apples, and I'm instead going to substitute towards eco-friendly apples, and so I'll buy more of those. So that positive coefficient makes sense. I also have a positive coefficient on family income. As family income goes up, so does my consumption of eco-friendly apples. Okay, here's another example of how we might estimate a demand function, but in this case, I actually want to estimate an elasticity. So I have the quantity and price in this model, but I'm taking the natural logarithm of quantity and the natural logarithm of price, and then I'm estimating my regression. So because of the properties of logs, what happens is the coefficient on the natural log of price is an elasticity. So in this case, the price elasticity of quantity demanded is negative 1.25. And to interpret that, we would say a 1% increase in price leads to a 1.25% decrease in quantity demanded. So I just wanted to show this to you because if you have a log on the left and a log on the right, you're going to end up with an elasticity. And it's a very easy way to estimate an elasticity. Okay, my last example is going to look at the impact of household income on health expenditures. So we hypothesize that healthcare expenditures, E, are a function of income, I, specifically that expenditures increase when income increases. So this hypothesis comes from the consumer choice model as well. When income increases, the budget constraint shifts out, and the consumer maximizes utility again by getting to a higher indifference curve on that higher budget constraint. Suppose we estimate the following for a sample of households, where E is annual household health expenditures and I is annual household income. So we get the following result, that predicted expenditures are equal to 2,000 plus 0.2 times I. So as income goes up, so do health expenditures. However, there are many other factors that affect healthcare expenditures. And some of those might be age. Some of those might be whether or not you have a chronic disease. There are many, many other factors you might come up with that affect health expenditures. And we might want to control for some of those. So in this simple example, I have added the price of medical services and age of the individual, or it could be age of the household head, depending upon whether we're measuring individual health expenditures or household expenditures. So what I found is that predicted expenditures equal 1,000 plus 0.13 times income minus 0.2 times price plus 0.8 times age. And what I really just want to show you is that we still have a positive relationship between income and expenditures. We have a negative relationship between price and expenditures. As medical services get more expensive, expenditures do fall. And as age increases, so do expenditures. Last, I just want to end with this thought about how econometrics, meaning regression analysis, is different from statistics. And Heckman says that economic theory plays an integral role in the application of econometric methods because the data do not speak for themselves on many questions of interpretation. So basically he means that we can run a regression with any data. However, what pops out is up to us to interpret. And interpretation is a lot easier if we start with the theory. It gives us a lot of insight into the results that we get from the data.